Hi everyone, in this video I am going to teach you on how to evaluate limit of a function, and I will focus on these five functions: polynomial, piecewise, rational, functions with radical expression, and complex fractions. So for example number one, we have a polynomial function. If this is the problem, this one is cubic, by the way. If it's cubic, quadratic, linear, any polynomial function, all we need to do is to substitute the c to x and then evaluate. So here our c is -2. You will substitute that to x, so negative 2 raised to 3 plus 4 times -2 square minus 3 times -2 plus 5. So negative, this is -8 plus 4 times 4, -2 square is 4. This is plus 6, and then 5. -2 times -3 is 6. This is 8. 4 times 4 is 16. 6 plus 5 is 11. 8 plus 16 is 24 plus 11 equals 35. All right, let's go to example number 2 now. And here we have a piecewise function. So if the problem is about piecewise function, you might encounter three possible problems. This is the first one. We have a problem that asks us to find the limit of this function as x approaches c from the left. Okay, so this is the left hand limit. So if that is the case, you need to look at the domain part, or the if part of the piecewise function, and you need to look for the less than symbol, provided that your x should be on the left side. Okay, and the formula that corresponds to that is the one that you're going to use. Again, so if it's a left hand limit function problem, you have to look at the less than symbol, provided that x is on the left side, and you will use the corresponding formula to evaluate the function. So here x is 1, so that means 1 plus 3 square minus 9. 1 plus 3 is 4 square minus 9. 4 square is equal to 16 minus 9, which is equal to 7. All right. There's another problem that you might encounter. We need to find the right hand limit. So if this is the problem that you will encounter, look at the if part or the domain part. You should be using the you should be looking at the greater than symbol, provided that x is on the left side, and you're going to use that formula that corresponds to that. So this is 10 minus 2 times -3. It's 10 plus 6, which is equal to 16. All right. Let's go to the next one. Now here, it's not specific like the previous examples. We just need to find the limit of a function as x approaches 5. And this is a piecewise function, still a piecewise function. So if this is a problem, we have to find both the left hand limit and the right hand limit. Okay, so let's solve for the left hand limit first. And again, look for that less than symbol, provided that x is on the left side, and we will use that formula that corresponds to that. So 2 times 5 plus 7. This is 10 plus 7, which is equal to 17. Our right hand limit, so look for the greater than symbol, provided that x is on the left side, and we will use that formula that corresponds to that. So this is 5 square minus 10. 5 square is 25. Minus 10 is 15. Now, since the left hand limit is not equal to the right hand limit, that means the limit of this function as x approaches 5 does not exist. Okay? It will only exist if the left hand limit is equal to the right hand limit. That would be the limit. All right? Next example, here we have a rational function. So for the rational function, we cannot just substitute or directly substitute the value of c to x, because if we do that, in some cases, or actually in most cases, you're going to have um, an incorrect answer. So to avoid that, what we need to do is to factorize everything first and see if you can cancel out something. So here, what we will do is we will factorize the numerator. This is x plus 2, x plus 1, right? 2 times 1 is 2, 2 plus 1 is 3. The denominator is x minus 2. So as you can see here, we cannot cancel anything. That means all we need to do is to plug in that 2 to all the x's. So this is 2 plus 2, 2 plus 1, all over 2 minus 2. So this is 4, this is 3, and this is 0. So it's 12 over 0, which is undefined. So that means that the limit of f of x approaches positive 2 does not exist. All right. Now let's see the next rational function. Okay, so here again, we have to factorize everything and see if we can cancel something. All right, so common factor of 3 and 21 is 3. Common factor of x squared and x is x. So this is x plus 7. And then the denominator is also x plus 7. And as we can see here, we can cancel out the x plus 7. So if you just plug in that negative 7 there, the denominator will be 0. This will be undefined. But if we factorize the numerator, we can see that we can cancel out that x plus 7. That's going to leave us 3x only, which means that we have a limit here, which is equal to negative 21. All right, another rational function. Here we need to factorize both the numerator and the denominator. So x and x, negative 24, that means both, or the two factors have different sign. Let's try 8 and 3 first. Since the middle term is positive, that means the higher number is positive. Positive 8 times negative 3 is negative 24. Positive 8 plus negative 3 is positive 5. So we are correct. In the denominator, negative 3 is the constant number. So the factors of that are only 3 and 1. The middle term is negative, so the higher number is negative. This is plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Okay, so we're correct. Okay, so we can cancel that x minus 3, and it's going to leave us with x plus 8 over x plus 1. Now we can substitute 3 plus 8 over 3 plus 1, which is equivalent to 11 over 4. All right, let's go to the next one. Okay, so here we have a function with radical. Again, here, if you just plug in that 8 to x, this will be undefined, so we cannot do that. What we will do here is we will rationalize. That means we need to multiply both the numerator and the denominator by square root of x minus 8. And at the same time, we will factorize that 5x minus 40. So common factor of 5 and 40 is 5. Then x minus 8 times the square root of x minus 8. In the denominator, if we multiply x square root of 8, x minus 8 times the square root of x minus 8, that'll just be x minus 8. And there you go, we can cancel the x minus 8. So this is 5 times x is 8, so this is 8 minus 8. And this will just be equal to 0. 8 minus 8 is 0, square root of that is 0, times 5 is equal to 0. Okay, so let's check the next example. All right, again, here, if you will directly substitute that 25 to x, this will be undefined, so we don't need to do that. let's try to multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate of that is 5 plus the square root of x, 5 plus the square root of x. And while we're doing that, we need to factorize the numerator. So 104, common factor of that is 4. 100 divided by 4 is 25 minus x. And then this is 5 plus the square root of x. This is 25 minus square root of x times square root of x is x. So here we don't need to use the FOIL method because this is sum and difference. All we need to do is to multiply the first terms and then the last terms. Now we can cancel that 25 minus x. So 4 times 5 plus the square root of 25. So 4 times 5 plus 5. 5 plus 5 is 10 times 4 is equal to 40. Right, let's go to the next example. Okay, so here I think what we need to do is we will multiply both the numerator and the denominator by the conjugate of the numerator. So the conjugate of that is x plus 12. That's a minus, so this is plus 4. And then let's factorize the denominator. It's negative 3 times x minus 4, right? So I take out that negative 3. Negative 3x divided by negative 3 is x. 12 divided by negative 3 is negative 4. Equals. So this is x plus 12 minus 16. All over... Hold on. We need to put x plus 12 plus 4 here. Okay, we need to multiply both the numerator and the denominator by the conjugate. So this is negative 3 times x minus 4 times the square root of x plus 12 plus 4. There you go. Alright, so x plus 12 minus 16 is just x minus 4. There's an x minus 4 in the denominator, and I believe we can cancel that. That's going to leave us with 1 in the numerator. This is going to be negative 3 square root of 4 plus 12 plus 4. There you go. So 1 over... Hold on. It should be like this. There you go. So 4 plus 12 is 16. Square root of that is 4. 4 plus 4 is 8. And then negative 3 times 8 is negative 24. So this is our answer. Alright, let's go to the next one. Alright, again, function with radical. Just like what we did in the previous example, we need to multiply this by the conjugate of, this time, the denominator, which is the square root of x minus 1 plus 3. So the square root of x minus 1 plus 3. Okay, so the numerator will just be equal to x minus 10 times square root of x minus 1 plus 3. And then the denominator will become x minus 1 minus 9. So that this will be equal to x minus 10, which means we can cancel that, this one. So now it's going to leave us with x minus 1 plus 3. Let's substitute that x, that 10 to x. So 10 minus 1 is 9. Square root of that is 3 plus 3, which is equal to 6. Alright. Alright, let's go to the next one. And I believe this is the second to the last example. Again, if you just directly substitute that 1 to x, this will be indeterminate, undefined, so we will not be doing that. So in a complex fraction, what we will be doing is we will try to simplify this by performing the operation. So let's combine this. X minus 1 all over 3 times x plus 1, which is, so let me just write this down like this. And then minus 2 times x plus 2 all over 2 times x plus 1. So let's simplify this. Let's put it this way here. So x minus 1 times the reciprocal of the entire denominator. So this is 2 times x plus 1 over 3x plus 3 times x plus 1 is 3x plus 3. Negative 2 times x plus 2 is negative 2x minus 4. So if we simplify the denominator, 3x minus 2x is x, then 3 minus 4 is negative 1, which means we can cancel that x minus 1. And that will leave us with 2 times x plus 1. So now we can do 2 times 1 plus 1, which is equal to 4. Alrighty. Okay, so let's answer the last example. I believe, again, here, if you plug in that 5 in our problem, this will be an indeterminate function. So we don't need to do that. What we will do first is, this time we will evaluate the entire numerator. So cross multiply. So 3 times 3 is 9, minus 1 times x plus 4 all over 3 times x plus 4 all over negative 2 times x minus 5, right? So the entire numerator is this, that 9 minus x minus 4 over 3x plus 12. So we will multiply that by the reciprocal of the denominator. So our denominator is only negative 2 times x minus 5. So this will be equal to 9 minus x minus 4 over 3x plus 12 times 1 over negative 2 x minus 5. Okay, so here we can simplify this. I think 9 minus 4 is 5. So this is 5 minus x. Now you might be thinking, oh, we cannot simplify anything here, but I believe we can simplify something. So, but we need to change the signs of this here, right? So that 2 will become positive, the x will become negative, and that 5 will become positive. So now we can cancel that 5 minus x. This is the same as negative x plus 5. Alrighty, and now we can substitute that 5. So 1 over 3 times 5 plus 12, right, times 2. So this is 1 over 3 times 5 is 15, plus 12 is 27, and times 2 is 54. There you go. So the answer is 1 over 54. So that's it for today. I hope you learned something. Thank you for watching and have a good one. Bye.